Hello chemists and welcome to Bale's Chemistry. In this episode I'm going to talk you through the calculations required when we add a small amount of acid to a buffer. This is 1.12 acids and bases on the AQA A-level chemistry specification and appears on paper 1 of your final exams. If you haven't already, consider subscribing to the channel so you don't miss out on the weekly videos, and if you find it useful, make sure you hit the thumbs up below. So before we consider the calculations for the process of adding a small amount of acid to our buffer, it will be useful to remind ourselves of how a buffer works in this situation. A buffer is established when an equilibrium is set up between HA, H+, and A-. There needs to be greater concentrations of HA and A- than of H+, as this allows the addition of the acid or base to be absorbed. When we add an acid to the buffer, the equilibrium shifts to the left, creating more HA and lowering the concentration of A-, and restoring the concentration of H+ to almost the same as when it started. Remembering what actually happens in this process is particularly useful in finding our way through the calculations later on. Before we can calculate the change caused by the addition of an acid to a buffer, we need to know the concentrations present of each species at equilibrium. This is covered in my video on calculating the pH of a buffer, and there's a link to that at the top of the screen now. We'll use a combination of these two equations depending on the data given in the question. When we add a small amount of the acid to the solution, three things will change. The number of moles of A- will decrease by the same number of moles of H+ added to the solution. That's because the H+ reacts with the A- to form HA. The number of moles of H+ will increase by the number of moles of H+ added because we assume that all the H+ added reacts with the A- to form new HA. And overall the volume will increase by the volume of the acid added to the solution. In this calculation there are four main steps. In the first step we need to work out the moles of HA and A- present in the buffer, along with the moles of acid being added to the buffer solution. In the second step, we need to consider the new volume of the solution along with the change in the number of moles of HA and A- caused by the addition of the acid. We then need to convert these new moles into concentrations. In the next step, we need to use all these values calculated so far to find the value for the concentration of hydrogen ions using the Ka expression. And in the final step, we'll calculate the pH from the concentration of hydrogen ions, so we now have the pH of the solution after addition of the acid. We're going to look at this question as an example. We're taking 1 decimeter cubed of a buffer solution which has been made using 0.5 mole per decimeter cubed methanoic acid and 0.2 mole per decimeter cubed of sodium methanoate. And we're going to add 15 centimeter cubed of 0.7 HCl to it. And then we want to calculate the pH of this final solution. In the first step, we're going to need to calculate the starting moles of HA, A- and H+. This is a relatively straightforward process using an equation which you'll be quite familiar with. It's really important that we don't forget to look at the volumes and make sure that we convert to decimeters cubed where required. In this second step, we're going to work out the new concentrations of HA and A-. We need to take into account the change in volume first. So we'll start off by calculating the new volume where we're adding the volume we were given of the buffer, which is 1 decimeter cubed, to the volume we're given of the acid being added, which was 15 centimeters cubed. Next, we'll work out the new moles of HA and convert that into a concentration. So we'll add that together from the moles of HA at the beginning to the moles of H+ that we had, because remember, H+ plus the A- will make new molecules of HA. And then we'll work out the new moles of A- and turn that into a concentration. Remember, the moles of A- will have gone down now because H+ will have reacted with the A- to form the HA. In this step, we're going to work out the value for H+ using the Ka expression. What we're going to need to do is to find the values that we've calculated previously in the question and substitute them in to find out a concentration of H+. And in the final step, we're going to calculate the pH using the minus log of hydrogen ion concentration to find a pH of 3.32. That's it for this episode of Bale's Chemistry. Don't forget to like and subscribe, and if you need more help with acids and bases, check out the playlist on the screen. Thanks for watching.